video presents two privacy-preserving tools, the Data Anonymization Service, DANS, and the Functional Encryption to Medical Data, FE2MED, developed in the context of the Medical Data Exchange Demonstrator of CyberSec4Europe project. The work has been performed by Miriam Villegas Jimenez, Raquel Cortés Carreras, and Juan Carlos Pérez Baun from the Blockchain, Identity and Privacy Unit of the ATO Research and Innovation Department. The main challenges this demonstrator faces are the creation of trust and secure e-health processes for sharing personal and sensitive data, preserving the user's data privacy at any moment. These systems must be GDPR regulation compliant and at the same time generate business opportunity to SMEs and service providers to the European digital market. The solution this demonstrator provides is the creation of a secure, privacy-preserving and trusted environment to data providers and data consumers for sharing sensitive data through a marketplace, in this case the COVID-19 Data Exchange Platform. This platform has been created by Dawex for exchanging the COVID-19 data retrieved from health authorities with researchers and doctors for fighting the COVID-19 pandemic. The data are secured by privacy-enhancing technologies by using a functional encryption tool, the FE2MED asset, and user data privacy is preserved by using an anonymization tool, the DANS asset.
The Dawex marketplace offers data from different domains including the health one. Searching data from the CyberSec4Europe project on the data catalog shows the privacy-preserving health records generated by the Medical Data Exchange Demonstrator. The platform provides to the data provider information about the project and the services for protecting and preserving privacy of data such as the anonymization service and the functional encryption service. On the other hand, the data consumer interested in the protected health records can check details of this offered data, such as the period of use. If the data consumer is interested in this data, is able to download the anonymized dataset.
Electronic health records gathered by hospitals and health organizations contain sensitive information, and the aggregation of this data is an invaluable aid for preventing diseases, take accurate medical decisions and research purposes. With the aim to protect and avoid a breach of the data privacy when these data are delivered outside the medical institutions, anonymization techniques and services like DANS must be applied, as anonymized data are excluded from GDPR regulation because anonymized data are no longer personal data. The identification of health records can be achieved by applying k-anonymity privacy models and using generalization techniques, preventing and mitigating as much as possible the user identification. The DANS asset is based on an open source tool called ARCS, commonly used for anonymizing sensitive personal data and supports privacy and risk models such as k-anonymity and L-diversity, and methods for transforming data like generalization or microaggregation. Also provides methods for analyzing the utility of output data. With the aim to increase the user experience and facilitates the management of this tool, a graphical user interface has been created and presented later on. The DANS assets is provided in two flavors, as a Java library to be embedded into the data provider system as a microservice which can be deployed on the data provider side and used by the data provider to anonymize data for sharing with the data consumers through the data exchange platform. The DANS service is available through the data exchange platform. The data provider leverages this service for anonymize the plain dataset as the next graphical user interface shows. Finally, the data provider is able to upload the anonymized data to the data exchange platform. The data anonymization service DANS and the graphical user interface shown here is developed under the CyberSecurity4Europe project. The anonymization process comprises different steps that can be seen here, and the first one is to select the file to be anonymized. The format of the files could be Excel files or CSV files. Once selected one, we proceed with the next step, that is selecting the different attributes that the file contains. We select age as the first one. We have to define now the attribute, the data type, the format type, and the attribute type. This case could be identifying, quasi-identifying, sensitive, insensitive, and we select quasi-identifying for age. So you can see information appears at the bottom. As quasi-identifying attribute is defined, we have to select the transformation method, and if we use generalization, we have to select a hierarchy file to be applied on them, and we select the hierarchy age. Once selected, we can go to finalize the definition and go for the next attribute, or resume if we finalize the definition of the attributes. By selecting next attribute, the age disappears on the list, and we can select a new one, gender, again the definition of this attribute, and the type also we are going to define as quasi-identifying, and again we have to define the transformation method and select the hierarchy file to be applied on it. In this case, hierarchy gender, and as you can see at the bottom of the screen appears the selected options. The next attribute definition will be for the zip code, again the definition of this attribute. In this case, the attribute is going to be identified as identifying, and the last one will be the disease attribute, and the definition of them will be for sensitive data, and you can see at the bottom of the table. Once selected them, we have to apply the different parameters for the anonymization, and quasi-identifying attributes appear. We have to select the k-anonymity parameter, and a sensitive attribute appears. We have to select L-diversity attribute. So this is a summary of the parameters selected, and we can submit it and anonymize the data, and the results are downloaded to your laptop. And first is the report of the anonymization process, and you can see the different features of the process, the number of records, the remaining attributes, and the different applied functionalities on them. Now we can open the Excel file, in this case the anonymized file, and where we can see that the different attributes has been anonymized, the age and gender. Regarding the functional encryption tool, the FE2MED asset is devoted to secure personal and sensitive data by an end-to-end encryption. It ensures the data integrity and the data confidentiality as well. With this type of encryption, only certain users are allowed to see the encrypted data. Also, the FE2MED is able to perform some computing on the data set, providing the final results to the consumers without revealing the source data. This asset is based on open source crypto libraries from the FinTech EU project. Namely, Inner product schemes such as simple DDH and Dangar DDH are used for statistics computations, and attribute-based encryption schemes such as key policy attribute-based encryption for selecting disclosure. For facilitating the management of this tool, a graphical user interface has been created and presented later on. The functional encryption to medical asset is deployed as service on data provider side for encrypting the dataset to be shared. This service is available through the data exchange platform. The data provider leverages this service for encrypting the plain dataset. The data consumer is able to use this service only for decrypting purposes and provide information to the data provider about the roles of the recipients. The next graphical user interface shows these processes. The functional encryption to medical data service comprises two graphical user interfaces for both the data provider and the data consumer. For demonstration convenience, both dashboards are presented in the same application. Although this service is deployed on the data provider premises, the data consumer only can access to the data consumer dashboard for limited functionalities. On the provider side, the encryption process is performed in several steps. The process starts when the data provider is looking for the dataset to be encrypted. Once the dataset is selected, it can be uploaded to the temporary repository, and a file identifier is provided by the service. As the access to the encrypted data is based on policies, the next step is create a policy data access based on the role of the persons to be allowed to see the data. To this end, a logical expression needs to be set, including the allowed roles. A list of roles is provided by the data consumer and is included for creating the logical expression by adding the allowed roles. You can add as much roles as you like. Once the logical expression is created, the keys for decrypting the data associated to this role are requested. The service provides an identifier for these delegated keys. The next step will be to set which roles are allowed to see the specific attributes. First, the attributes is selected, and then set the roles allowed to see the attribute. After setting is finished, the encryption of dataset based on the policy and the attributes is requested, obtaining an identifier of the encrypted dataset. The next step allows the data provider to download the encrypted data or to move to the next step. For sharing the encrypted file identifier with the data consumer. After submitting the information, the data consumer will receive the identifier. Moving to the data consumer side, for demonstration purpose, the creation of the customer roles list is shown first, but we will be back to this functionality at the end. Skipping the creation of the roles list, the encrypted file identifier is displayed and the data consumer is able to decrypt the dataset. For doing this, it is necessary to set the roles who are allowed to see the encrypted dataset. After decryption request, the service provides an identifier of the dataset containing the decrypted attributes for the specific roles. Now the data consumer is able to download the file. Back to the creation of the list of roles functionality, first it's necessary to set the name and the short description for each role. You can create as many roles as you need, so once the list is created, this list will be sent to the data provider and can be used for creating the policy on the data provider side, as you can see in this part.